Welcome to solverfy.
So part A wants us to trace the image to show that the image is virtual, and it wants us to estimate the image distance here, okay, or d sub I. So from the ray diagram, which I have drawn, we see the convex mirror here in green, okay, and the object in blue. The image produced on the other side is a virtual image, right, also in blue. And we can see where it crosses the black line then would be the focal length. So from the ray diagram, it is seen that the image is virtual, like I said, and we can estimate the image distance to be about a third of the radius of the curvature, which is about -5 centimeters. So image distance, we'll call it d sub I, is approximately a third of the radius of the curvature, which we were told was 16 centimeters, but it's negative because it's virtual. So this is approximately -5 centimeters, just from estimation. Okay. I also wrote down up top what we were given in the question. The height of the image originally, h sub 0, is 3 millimeters. D sub 0 is the distance from the object here, which is 16 centimeters, d sub 0. And the focal length is about, since it's virtual, it's -1/2 r, which is equal to -8 centimeters here. So that would be the focal length is -8 centimeters. Okay. So using this information, we can go ahead and start here on part B. Where we know that the relationship is 1 over the distance to the object plus 1 over the distance to the image is equal to 1 over f. Therefore, the distance to the image, which we were asked to calculate for part B, is going to be equal to the distance to the object times f divided by the distance to the object minus f. So plugging in those values from this previous page here for d naught and f into our equation, we find this is equal to -5.3 centimeters, which was pretty close to our estimation from part A. We can box it into as our solution for part B. Okay. Now for part C, where we're asked to find the height of the image, we can use the fact that the magnification here is equal to the height of the image divided by the height of the object, which is equal to negative distance to the image divided by distance to the object. Since we know everything here except for the height of the image, we can go ahead and solve for height of the image and find that it is equal to the height of the object multiplied by negative distance to the image divided by distance to the object. In the previous question, we found the distance to the image was negative, so those negative signs are going to cancel, and we find that the height is about 1.0 millimeters. We can box that in as our solution for part C.